InteractivAI 5 is our next installment, or next version, of a powerful deep learning tool that enables you to rapidly move through your data and create predictions that are geologically significant and accurate. What we're going to do here is we're going to go through a few new features, and I'll highlight some of the new functionalities that InteractivAI 5 brings. But before we do that, let's ask ourselves a question. So the question that we've been asking ourselves is, should I implement AI methods in seismic interpretation? But that question has changed this year. The first question's been answered. We are implementing AI methods for seismic interpretation, so now the question has changed to how do we responsibly implement AI in seismic interpretation? So let me give you an example of what I'm talking about. This diagram shows a traditional deep learning approach where you start with your data and you have a pre-trained model. The entire goal of this approach here is to perfect the model so your data fits into the model. So you start out with your data, you start with the pre-trained model, and then depending on the application you use, you add labels, you parameterize the network, and then you train. After you've trained, you generate a probability volume output, and then you analyze the results. And more likely than not, at this point, we have an iteration stage where we have to go from our final result back up to the parameterization, tweak some parameters, and then run the process again. So what this means is you're spending days or more perfecting a model. Now let's contrast that with InteractivAI, an interactive method of deep learning, where we start with our data, same thing, but instead of using a pre-trained model, what we're doing is we're labeling the data to define our model. Once we have our labels and our initial training data in there, we train the network, and then with interactive deep learning, you can analyze the results in real time. So what this means is we're moving from an iteration stage to an interaction stage, where you're interacting with the network as it's training, you're using your own experience and the labels to steer the network in the right direction. Only after we've analyzed the results and we're happy with them do we generate a permanent probability output. So the time you spend with interactive deep learning is more on the scale of hours rather than days or more. Interactive AI, like Bita said earlier, is a human-centric or human-powered interpretation tool. Now, what makes interactive AI unique is that when you start training a network, the network does not know anything. You are teaching the network everything it needs to know, so these networks are specific to the data set that you're working with. There is no black box in interactive AI. We've taken the black box out, we've exposed the process, and this puts the user, the geoscientists with their experience, in the center of the training process. And of course, this results in a much more comprehensive, faster and higher confidence output when compared to manual interpretation methods or traditional deep learning interpretations. Interactive AI 5 specifically. So Interactive AI 5 has a bunch of new features that we think are going to really improve your quality of life, so to speak. The multi-volume training, this allows you to train one network using one label set on multiple input data volumes in parallel to generate a combined inference. So we'll be looking at this in much more detail soon. We've also added a 3D viewer, and we think in 3D. The Earth is in 3D, so we should work in 3D. And the real value of the 3D viewer is the ability to analyze the inference results or the predictions from a bunch of different networks together in 3D space, so you can rapidly move through your data and QC the quality of those results. Labeling and adding labels is now incorporated much faster into the training process. So we don't have to wait for an epoch to end before we fold the new labels into the training. We can do this as the network is training, and these labels get integrated and implemented in the network immediately. We've done some UI changes that make things a lot easier to find and identify. And we've also taken our AOI mask, our area of interest mask functionality, and we've enhanced that a little bit to add quite a bit more data that allows you to focus only on the volume in the larger seismic data set that you're interested in. If you saw Katie's talk earlier, she made excellent use of the AOI mask functionality by perfecting a network in a smaller area and then removing that mask to apply the network to the full 3D data set. So this eliminates the need to crop data or do anything like that prior to using it in the deep learning process. Multi-volume training allows you to focus the network specifically on certain components of the seismic data that are relevant to the question you're trying to answer. So what we're looking for is the co-location of these unique attribute combinations during multi-volume training, which results in a much higher quality inference in a much quicker time frame. The higher quality inferences mean that you can readily take those inferences and convert them to labels. So you're really quickly adding high quality labeled data to your network via the inference. This allows you to reduce your manual labeling effort and also uncover relationships between these multiple volumes that you might not have noticed or you might not have picked up to begin with. Another very, very big selling point of multi-volume training is the ability to reintegrate petrophysical models, uncertainty volumes, inversion, QI results into a network so you can use these QI and calculated volumes to very effectively train a network for a very specific purpose. This video is showing a single volume inference from amplitude data only. And what I'd like to focus on, let's focus our attention on this salt overhang over here. The yellow inference shows the results from just a single volume amplitude network. And when we use multi-volume data, we're able to use, or multi-volume training, we're able to use multiple volumes to train the network the way that we want it to be. So let me pause this right here for a minute, and there are a few things that we can tell right away. The yellow color is the amplitude inference, single volume amplitude. The red color, which is orange in overlap areas, the red color is the results from multi-volume training. You can see right off the bat, multi-volume training is much quicker to converge on a reasonable result without false positives. And when we look at the multi-volume inference, which is again going to show up in red, we'll be able to tell that there's a very important detail. It's small, but it's important in this area of the salt overhang. So when we remove the amplitude inference, you'll notice right away that the multi-volume network was able to capture this very small piece of sediment that was trapped in the salt as the salt was moving around. So when we use the single volume training with amplitude only, we're getting results that you'd expect from amplitude, just generalized results. But as we use multi-volume training, we're able to add attributes or other data sets that are relevant to this to help train the network more accurately and effectively. Multi-volume training delivers a lot of value in terms of the ability to improve your training efficiency and accuracy. If you look at these two images, the first thing that probably pops out at you is the difference in quality. On the left, we have the single volume with the amplitude. On the right, we have the multi-volume training. And you can tell immediately that quality is a whole lot better, so your confidence increases in the results that you're getting. The second thing a lot of you have probably noticed is the time it takes. So with 28 minutes of a single volume network training on amplitude data alone, this is the result we're getting. With 2 minutes of training with the multi-volume network, you can see the results we're getting are a lot cleaner, they're a lot more confident, and this confidence in the results actually translates into reduced costs and risks up front. By understanding the subsurface better, you're raising your probability of geologic and economic success, and you're getting interpretations that you can actually put into your prospect queue much, much quicker. So more high quality interpretations in your prospect queue means you have more high quality prospects to review, and this will drive up your success rate at the end of the day. We've also implemented a 3D viewer, and what the 3D viewer can do is you can co-render different attributes together and view them. This is chaos and amplitude, but the real value of the 3D viewer is the ability to look at multiple inference results and how they're associated and related to one another. You can see over the active salt diapirs, we have radial faulting like we'd expect. And we can also see some faults that exert structural control over the way that the salt, over the structure of the salt and the geometry of that salt. So the 3D viewer lets you look at a lot of data at the same time in a 3D view like we're used to. You can look at the inference results much, much quicker and then rapidly move through these results, find places where the network might need help, and you can improve that network. We've also enhanced the AOI masking. So whereas before the AOI masking was simply a cookie cutter, we've now implemented the ability to constrain that mask in a Z dimension. So you can define the top and the base of that mask. These mask polygons can be translated. You can add more than one mask polygon to an AOI mask. And you can also edit the existing masks by just simply rearranging the nodes. Here you see I'm adding a second polygon. This is the same AOI mask. You can merge these, and you can also dictate whether these are inclusion or exclusion polygons. So this masking capability has been greatly enhanced so you can focus your training on a specific piece of the data that you're interested in, perfect that network, and then open it up to the rest of the data set. So InteractivAI, what it delivers is the ability to create much more accurate interpretation results in much, much faster time frame than even traditional deep learning would allow you to do. The quicker you can move through your data and obtain solid, confident results, the more you can maximize the number of scenarios you're running. So instead of a P10, 50, 90, you can be P1, P10, P25, 50, 75, 90. The message here is InteractivAI enables you to run more cases in the same amount of time that it would take using traditional deep learning methods or manual interpretation. The networks in InteractivAI allow you to capture features at a much higher level of detail, which means there's quite a bit more confidence in the results that you're getting out. InteractivAI is extremely flexible, so you can use the same basic network architecture and network type to train on anything you can see in the seismic. Salt, faults, facies changes, sky's the limit. If you can see it in the seismic, you can train a network on that feature. So this leads to much more comprehensive and confident results at the end, which drives up our ability to make more informed decisions revolving around these data.